The weights, W, of carrots sold at a supermarket have been found to be normally distributed with a mean of 142.8 grams and a standard deviation of 30.6 grams. In other words, W is a normal with 142.8 and a variance of 30.6 squared. We want to determine the percentage of carrots sold at the supermarket that may weigh more than 155 grams. So we're just after the probability of W being greater than 155. So that's just going to be using our class pad. So we're just going to go interactive, and of course it's a continuous distribution, normal CDF, and we go from 155 essentially to infinity with a standard deviation of 30.6 and a mean of 142.8, and that's 0.3451. Carrots sold at the supermarket are classified by weight as shown in the table below. We want to complete the table providing the missing probabilities. We just worked out that W is greater than 155. So if we want greater than 210, what we could do is just subtract this from the answer we have on the calculator. And that will give me 0.0141. Sticking with the 4 decimal places that we've already got in the table. And then we know that all of these must add to 1. So I'm just going to do 1 take away 0.5131, take away 0.3310, take away 0.0141, and that gives me 0.1418. So, of the carrots being sold at the supermarket that are not of medium weight, so we're going to ignore these ones here, what proportion is small? So that's going to be 0.1418 divided by everything except this. So that's going to be 1 take away 0.5131. So I've got 0.1418 divide by 1 take away 0.5131, and that gives me 0.2912. Finally, the supermarket sells bags of mixed weight carrots with 12 randomly selected carrots placed in each bag. If a customer purchases a bag of mixed weight carrots, determine the probability there will be at most 2 small carrots in the bag. So this time we're looking at a binomial distribution. There are 12 carrots in the bag, so that's 12 trials, and the probability of small is 0.1418. And we're after the probability that there are at most 2, so x is less than or equal to 2. So this time we're going to go for discrete distribution, and it's a binomial CDF going from 0 0.22 with 12 trials and a probability of success of 0.1418. And that gives me 0.7637.